today is on BIM workflow, and I suggest request Trinath to continue, please.
Yes, ma'am. Yeah, let me share my screen. Okay, so I actually should say that we already started on the BIM workflow. Basically, this is to show how we are doing in house and how different stakeholders of different projects are bringing in their information and the way it is being put together and how a project is being handled during the construction phase of a project. So we talked till BIM 360. So let me just jump ahead. Yeah. So we covered till here. I will open up the projects and show simultaneously later on, but I think we can continue with the presentation for now, and then I can show everything in the system later. So let me just cover the presentation part of it first, and then we can go over that in the later session. So uh, the next one is Procore. Procore is pretty much similar, where it has a documents repository as well as a model upload location where you can upload your models and then do coordination review. And this is like an interface look where how it looks. So Procore can be accessed just by a browser. So you just type in procore.com, log in your information depending on the credentials you are given to the project. You will be shown. So this is one of the project which is going on right now, and although it is not totally used to its fullest, basically this is being used as an RFI tracking service as such. So you can see there are 54 RFIs for this project, of which 29 are overdue in the next 7 days. There are 18 which have to be done, um, and then you have seven uh, later. So you have the number of submittals done, you have inspections track, and then observations. So basically when a site is being constructed, there is inspection officer keep always checking the progress, and whatever other observations got in his inspection are being tracked over here, which can basically uh, specify a specific stakeholder that he is behind schedule, or there is some change from what is being decided to what is being constructed on site. So those kind of discrepancies are brought up. So this all, as I said, this project, although we are not using it to the fullest of what Procore can do, uh, but it is like a standard location where we go and check for any RFIs which have been resolved or which are uh, brought up. So those kind of things. And Procore is actually taking a next step where it is going to integrate coordination meetings in a way that you can track different people according to which location they are reviewing. So this feature is not available yet in the other interoperability tools which we were talking about, where you have like an overview. So if in a big group meeting you have different people who are attending it, and uh, each one is looking at a different location, so you know specifically where which person is, and if a certain item is being discussed, um, and you know specifically who is at which location, right? It also gives like a key plan of where each person is in respect to which level. So that is another interesting thing. So this is like a snapshot of a tablet interface, where you can just walk around the building with the tablet. The other feature which this also integrates is, depending on your location on the site, you can just use your iPad to look around the virtual model with respect to what is being constructed on site. So most of our projects which we are doing with this drywall partner of us in of our US partner, they implement this where the field inspector or the field manager carries around this tablet and has overlap of the virtual model to what is being constructed on site, and takes a snapshot and sends us where there are discrepancies or anything which we have to focus on. So those are like very clear, and there is no loss of information on which location what has to be changed, and those kind of rudimentary unwanted discussions are totally negligible now with the current tools we have. um, then we have BIM track. So this is, again, each one of these does pretty much the same. I'm just showing all the different tools which we are using currently for different projects. So it all depends on, in US it all depends on uh, the BIM execution planning, like uh, BIM execution plan, which is being developed by either GC, the general contractor, or BIM expert, which who is brought in to manage the BIM cycle of the project. So uh, so they dictate what are all the tools which are being used for the project for specific tasks, and and what has to be used where. Okay, so this is BIM track. This also has the same functionality, but let me just, yeah. So this we use specifically for tracking all the RFIs to get the locations, as well as a snapshot or a snippet of what is the issue, as well as clashes. So specifically this for this project we use BIM track to get like a snapshot of what happened at what location, and it also gives you like a priority. So anything which is in blue shade, it is low priority. Anything which is darker shade, it's usually critical, and then you have a medium shade which is priority of medium. So and like you also see if an issue is open, closed, so you have that indication as well. um, and specifically you can also like see what is the RFI number and which is relating to which level of the project. So these are basically thumbnails of the actual thing which is happening on in the virtual model. Once you click it, of course, it'll basically zoom to that location and give more details on what's happening. So there is a project which we are doing where they don't even specify what or where this is happening. and they just instruct at this so and so location we want you to change so and so thing, doesn't matter what. So what we do is we just track it with the number, so the issue number. So we just search for it with the issue number over here, and then it'll filter out to that specific issue, and then we'll just click on it to get the grid locations, the room number, or even the XYZ of that specific location. The other thing also this can do is it can also like export Navisworks viewpoints. So we can import those viewpoints into Navisworks and then use that directly in Navisworks and check. So most of these tools have some kind of integration towards back to Navisworks, because end of the day, even though you're doing like a cloud hosting of these services, individual stakeholder, when it comes back to his specific task, he will be uh, like he will be focusing on his specific task, right? So if I'm a drywall subcontractor and I want to focus on a specific wall and I have to change something, for that I need to know where it is. I need to have like an in-house Navisworks composite file which has those all the trades, and with that viewpoint, I can check that specific location and update it. So that's BIM track. And then we have Revisto. I think Adnan sir started talked about Revisto a bit. He showed the 3D functionality of it, but the way we are using Revisto for this specific project, there's another project which we are dealing with where we are asking specific questions to the client directly, and then we are getting responses right away. Like uh, the the feedback loop is around like 2 days. So as soon as we send, within 2 days we get back a reply, and it is done. Actually, it can be far better than that, but like we did one project where the feedback loop was in 1 day. 1 day in the sense, because we are interacting with US clients, the day end of our day we'll submit all our questions. That's their morning, and they'll reflect, get the answers back, and the next day morning we have the answers and we can just take it forward. So the feedback loop is very less, like the time spent on that is very less. So yeah, for this project, if we have any specific doubts or any specific issue which we want to raise to the client, we raise it with this. But the best part with Revisto, what we saw is its functionality to overlap these 2D drawings onto a 3D interface, where this is just a section which is developed in Revit. It is one of the views which are developed in Revit. But what Revisto does is it understands the section cut location. It understands the view range which is given, and it overlaps that automatically. There's nothing that we have to do as such. We just click on that specific detail and click 3D, and it'll jump. You see this 2D, 3D, right? So as soon as we click 3D, it'll overlap this 2D view onto the 3D image, and we know exactly what or at which location we are talking about. So uh, this is being extensively used for our field, where they're actually constructing walls, right? So because we are like a subcontractor um, for the drywall. So uh, like if they want to see what exactly is happening for that wall at that location, they can, irrespective to even if the drawing is done, like this is like the extension part where even you see nothing is yet populated in the model background. But if they want to understand what is happening for that specific wall from the drawing set, uh, so they can just click on that wall and then see it overlap with the model and get an inference from the model understanding what is happening where, and understand the the construction part. So the field manager and the field persons have very less time spending to understand different drawings when it is a visual right in front of them, and it explains uh, the the constructability visually. So these are kind of the different interoperability tools which we use in-house, and there are quite a few others, but what all we used, I kind of thrown some light on those specific tools. So now coming back to the whole term building information modeling, right? So we, like till now, whatever has been covered talks about the information part of it. And now I'm focusing to the modeling part of this thing. So uh, even though we say modeling is like a visual representation of information, there are different techniques in which you can make the model more effective, more design specific, right? So if you do it in a certain way, it enhances and it gives more functionality to that specific model. So even though the whole modeling, it started off with this parametric modeling, right? So you have like a specific shape.
Hello,
Yes,
sir. Recently, you have shown the Revit though.
yes,
Looks like it also means collaborate all the services, structure, and all these things, all the engineers. But
yes.
navies work do the same thing. So, is there any difference between navies work and the Revit zone? And if there is yes, who is better to use? Which one is
Yeah,
better to use?
yes. So uh, so basically, if you understand the all the tools which I have to take a step back. Let me just. So all of the tools which I showed over here pretty much do almost the same thing except for Bluebeam. Bluebeam is specifically for 2D, although it can open 3D PDFs, but no one actually uses it. So pretty much all tools which I was talking about does kind of clash detections, does overlap all the different models from different stakeholders and shows them visually. Each tool has its own ups and downs. It is like you have different tool which can do these things, and when you ask which is better, I would say each tool has its own up and downs. It's the same answer, but uh, to kind of bring light on what is the differences between Navisworks to all these interoperability tools which I talked about is Navisworks does not have like a server. Right, that's what I was mentioning when I was talking about Navisworks. End of the day, you need to have all the files at one location, which is accessible by you when you compare it to all the others. So let it be like BIMTrack, Procore, BIM 360, and Revisto. All these interfaces are approachable just by browser. So you don't need to know which model is uploaded, who is uploading what. Um, you just need a browser to see the model. Okay, so there is a total difference between Navisworks and these tools if you understand it. So if we have Navisworks, like if you're talking about Navisworks, you do need to have Navisworks Manage or Freedom, depending on which version you have it. So or which functionality you're going to use in Navisworks. If you're doing clash detection, you need to have Navis Manage. But apart from having the software, you do need to have each and every file as well, right? So each and every stakeholder's file, you need to have it together, like combined together, and then that's when you can do clashes. But the the good part about all the other tools is you don't need to have a software. First of all, you just need a browser, but of course you need to have the account and registered with them with whatever credentials or the access. But once you have that, you can run clashes between your models to other models, irrespective to even if you have the file or not, because they are just uploaded onto the cloud, and you can run clashes between them and just see. So even if the in charge did not run clashes between your files to others, you can do that by yourself and then get it done, and you don't need to even have the files of the other stakeholders. Now this brings back the lecture from yesterday. Santosh sir was saying who is uh, who is in command of the model, which is once it is made. The direct answer would be the owner, because end of the day he is responsible for the building. So um, although there are people who can debate with that notion, because everyone is giving their fullest information. Like say if I'm a stakeholder, if I'm a structural guy and I'm giving my full information in the model and I'm uploading it, once I upload it, uh, it's like anyone can have access to this information, and they can use it. Of course they cannot change it in these interfaces. They cannot change my model. They can reposition it, they can move it as such, but they cannot change the specifications which are given, right? It is not like a model editing tool. It is just a visualizer. You can just see it, you can move it around, but you cannot change the shape or which is given by me. So if I have a column which is specified at a specific size, once I upload this model, that column, irrespective to where it will still remain the same size, right? So no one can modify it. So that's the good part. So your actual intellect knowledge which you're putting it is not uh, totally taken out. So this would be like a collective uh, uh, motivation for each and every stakeholder to give their fullest information for the betterment of the project. Because end of the day, it is the project has to be completed, and it has to meet its deadline, it has to meet its milestones and its financial requirements. So uh, different tools give uh, these visualizers, or all these interoperability tools give uh, a view to see your files, and to see the constructability of the project. But once everything is finalized, it will be reflected back onto the construction, and then the whole problem solving is done not on site. It is done beforehand, so that everything is planned, and on site there is very less time spent, and the work is done quickly. So hopefully I kind of answered it. But yeah, when you compare Navis to Revisto, going back to your question, Navisworks is an offline tool. You can just open, you need to have all files with you. And then once you have all the files, you can navigate and do all the things which you can do in Navisworks. Revisto is a server based, so everyone can upload their files there. You don't need to have each and every stakeholders files. You can view them, you can do you can navigate through the model. And we pretty much, we don't like, we haven't used the any clash detection kind of stuff in Revisto in-house. Like, we don't have hands-on experience on it, but for the most part, what we use that as a tool to explain our clients that there is a specific issue at specific location. And then they can like, the field personals can just use tablets, click, and then see what is happening for a specific wall, and then check with regards to other trades. Okay. Yeah. Any other questions, or can I continue? Okay, I take it I can continue. So
Okay, thank you.
yeah, thank you. So uh, modeling. So any BIM tool which you're using. Of course, I'm using Autodesk Revit. You can use ArchiCAD. You can use Bentley's MicroStation. So irrespective to which BIM tool you're using, you have this functionality of adding these parameters, or basically um, adding more information to a specific element. And depending on that information, that specific element changes its shape. That's what it is called as parametric modeling. So if these parameters are added uh, in the right way, in the right sense, it is then, like, if it is done in the right way, then your element should reflect what visually the space which it is occupying according to the parameters. So in this case, this is like a stool which is of height, length, and width of whatever parameters are given here, and it has some material, base material and top material, right? So all these are considered as different parameters, or each of these can be changed, and as soon as it's changed, it reflects visually in the model. As well as once this is uploaded, it reflects all these information. So if you remember the wall example which I showed you, the data, so if I export this specific stool or online, or even in Navisworks, if I open it in Navisworks, it will give these information. So basically, it will show height is so and so, length is so and so, width is so and so, and basically that's where it's getting those information from. So you can understand the length of parameters, the broad scale of parameters which are embedded in each element when it is created in these BIM tools, right? So I want to kind of show a hands-on session on kind of how these influences. Uh, Let me just minimize all these. I'm starting a new Revit session. Should have opened. So these files, I will be showing one of the projects which we are working currently, and The files are so huge from the server that like we just need to leave it on and it'll open in like 45 minutes. So even before we come to the office, we have all of this automated. So basically it'll switch on Revit, it'll switch on, it'll open the file for us, like whichever file we want. And at a certain time, like say 9:15, it'll activate, it'll open the files which we want, and 10 o'clock when we are in office, we have the file open. So you can all do all these. There are softwares which track your mouse movements, and you can record your mouse movements, how you're doing it, and then schedule that those mouse movements are run at a specific time, so that you don't waste time in doing mundane tasks. So just I in the break I opened bunch of these files and I just left it so that once uh, we are done with our break after lunch, I can show you the projects. So let me see something once again. Yeah. Um, before we talk about modeling, right, I wanted to show a location. How do you add location uh, to a Revit file actually? So I can show you that right now. So just give me a second. Okay, let me just start a new project. So this is like um a quick way how you can find different locations, and then with very less knowledge, how you can give almost accurate geolocation for geophysical location to your Revit files, or even any BIM file. Um, So the reason why I am opening both Google Earth and Google Maps is Google Maps gives you a good interface to find latitude and longitude, while Google Earth gives you a good interface to find the altitude of a certain location. So let me just go. Okay, in order to lessen the time to search a specific empty plots where they're like a dummy project, I went ahead and searched some locations beforehand. So this is one in Vizag near to Inox, where there is an empty land where, let's say, if this is the project which we are kind of tackling and we want to know the exact geophysical location of this, and we want to add it into our project. So this is like even before even before we get survey information, as soon as we get the project, if we want to get that information, right? So I'm just going to uh, search for those latitude and longitude. Of course, in Google Map, you can search according to the location. Once you get to a location, you just click on it, and uh, if you just click on a location and then right click it, you have an option to just click on the top one where it will copy the latitude and longitude on of that specific location, right? So all you have to do is just one click, it'll drop that pin, right click it, and then click on the topmost one, and I get the specific latitude and longitude of that pin. Okay, so very easy and very quick way of getting information of that specific location. So this, for this site, I chose one corner, um, some some random corner. There's no specific reasoning why I chose that, but you see, as soon as I gave that location in Google Earth, you can see over here, it gives me like an elevation or an altitude of that specific location. So it is approximately 44 meters from sea level, right? Throughout the site, it varies, but it's approximately 44 meters. So let's say I want to replicate that in my project. So I just had a client meeting and I just want to start off locating my project. So first thing I would do is I would go to manage, and then there is location. So this is where you first kind of give where the location is. In Revit, usually by default it has Boston, MA, because Revit, when it was first created, it was created by MIT students in Boston. So it will go to Boston, but you can type in your latitude, longitude, and it will pinpoint to that specific location right away. Okay, so I got the location, but one thing we tend to forget as soon as we get we give this location is it also gathers the weather data around it. Okay, so that is the backdrop what BIM tools can do. They get an average or reference uh, feels like temperatures or the actual temperatures of the weather data around that site, and it'll gather that information and keep it with it. So if you are engaging in any solar analysis or energy analysis for future, it'll be a really good start for it, right? So that's number one. Okay, so first we gave its location. Now we are trying to specify where exactly this project is. Of course, we gave a location, we gave latitude and longitude, but for Revit to understand that location, it in site it has this project base point and survey point. So it has to be reflecting those information. So what you can, the quickest way you can reflect it uh, is by just clicking on the survey point, okay, and then typing in the values of each of these. Okay, that's one way to change it, but there is another way of doing this. So I was talking about this cat to earth add-in, right? So let me just log in. Okay. So once you logged in with your user, once you registered, this is a freeware, so you don't need to like pay for it as such, but there are ups and downs for that as well. So I'm just going to paste the latitude, longitude, and it'll zoom in to that specific area. It doesn't goes to the site directly, so you have to direct it to the site. So this is the site which we kind of chose, right? So let me there is a drawing mode. I'll draw, and I'm just going to start drawing kind of the boundaries, approximate boundaries, not exactly. Okay, and then I'll finish it, so it will close whatever rough loop I did. And there is this checkbox. You can add building layer information, and then I'll switch it on, and I'll do save surface. Okay, so this you okay, first of all, to get this plugin, you can go to Autodesk store and then search for cat to earth, and you will get it. You can install it. Once you installed it, you will see this tab in your Revit. But yeah, once you have that, you can just click this get surface, and you just hit yes for if you want the building information. And then what it does is really interesting. So if I just go back to my Revit, you see that sketch which I drew in the browser. It's that is this exact sketch. So it is a rough freehand sketch which I drew, just outlining the border of the project. But it went ahead and made a topo surface which kind of which is almost equal to the GIS, publicly available GIS information for that specific location. And then it also gathered any publicly available GIS information for the neighboring buildings as well. So it brought in all this information just by uh, drawing uh, the outline of the project, saving it, and then as soon as I click get surface, it did all this. Okay, so pretty interesting and very quick way of getting an outline. But we still have not yet placed the geophysical location, right? So I'll be doing that now. So I will select. So the thing is, as soon as you open site in a fresh file, you have project base point and survey point both overlapping at one at each other. So basically, survey point is the triangle and the circle is the project base point. Okay, so we want the survey point to match to the latitude and longitude, whatever we are trying to uh, get. So it is this corner that we want. Okay, of course, this is all like a rough fresh way of doing it. Once you have the survey information, once you have the surveyor CAD drawings, you can get the coordinates. So under manage, you have acquire coordinates. So if your link file has that information, it can acquire it directly. But this is like a rough way of showing you how you can do the same thing in Revit with none information whatsoever, right? So I moved the survey point to that location. Now I want this to match that latitude and longitude. So I will copy uh, the information under manage. I have yeah, specify coordinates at a point. So I have this thing. I can click on that point. As soon as I do that, I can give it the north south information. So it is pretty much the same latitude, longitude information what you're gathering, and you just enter it. Now the elevation, you remember it was 44 meters. So this is the good part. It will automatically update if you enter in. Okay, so that's done. And this is actually the like the true north. So you see it brought in the buildings according to how they're oriented to the north, right? So we want to establish the project north. Okay, so what we can do is you need to be, your view should be oriented in project north, and then you go rotate project north. Okay, so you go under position, rotate project north, and then you can, it will give you different options where you can also align a selected line or plane. So if you select that from the file which we got, okay, so someone, if now we are relying a lot on the GIS information, I'm sure there will be people who are not happy with that. But if you have a GIS information which is reliable and which is very good, you can definitely use this to orient your stuff. So I'm just going to move my survey point. I think that kind of changed the settings. I'm just going to make sure that they are right again. And then okay. And once that's done, I can just fix that. And basically now I can specify my project base point. And you see, as soon as I click my project base point, now this is reflecting in accordance to these in this information. So now it is perfectly geolocated and you can start working. So, and also it has the north information as well. So if you change it to true north, your project will be located correctly. And the next part of this is you can also export it back to the GIS information. So once you have your model done in Revit, you can export your model back and make it more richer. So you can add more information. It will actually bring your model over here and then show it. So it is really interesting. But yeah, so this is like a quick way of getting your project located correctly in Revit, and also getting the right heights or the site information into your project. Okay, so that I actually got two sites which I wanted to show. So when I actually first experimented this with the Vizag region, I did not get any building information. So within this time frame, someone actually added this information for, so it was good. So I just wanted to show one in New York, Brooklyn, where you get all the neighboring buildings as well, which is publicly available GIS information. But luckily we have that for Vizag as well. So it kind of skips that step. So you kind of get the neighboring building height according to what is there in the GIS, and you can work on your project. Yeah, so that's like a quick tutorial on locating your project correctly in Revit. So I'm not going to save it, but I do have like a saved version. So I will share these if anyone is interested to see. Okay, so modeling, there is parametric modeling. So let's just, so in Revit, there are two things like models. Models is basically like the project, and families is like furniture or anything which is done not on site can be considered as family. So I just want to explain the concept of parametric modeling. Um, uh, so I will just show one quick example. So instead of doing everything before you, or to go through this whole process of doing it, I'm not going to do that here. I made one family already. So I'm just going to show the functionality of that. That's the concept which I want to focus on, so that you understand what parametric modeling is. So I will start a project. New project. Right, and I will bring this family into the project. So load into project, and as soon as I load it, it will give me functionality to add those. So basically this is like a cube. It doesn't have any other information in it. It's basically a cube with material, height, length, and width information. So the way it is set up is in the family, or in when I'm editing it, what I do is I have this width parameter. So if this is called as flexing of family. So if I want to test if it is working, so I just type in 150 and hit apply. You see the width changed to 150, and this also updated itself. So like you can basically check what you entered, and you can check if it is parametric or not. So once I load it into the project, now this becomes totally parametric. So that is what the term parameter means. Like you can change this to whatever, say 2 feet, and then the model gets updated and reflects that 2 feet then and there. So this is like the conventional like parametric modeling. So your families, or your yeah, basically your families have to be parameter rich, so that when you actually bring it back into Navisworks to review those, all these parameters are reflected and it shows those values, right? And you can see that it is doing volume by itself, right? I did not actually add any parameter called volume over here, you see. So while I'm creating the family, I did not add any volume parameter, but Rivet intuitively did it by itself. So that is really interesting, that there are certain parameters which it does it by itself, and it gives you those information as well. Right. So this is the conventional parametric modeling. It is there for any BIM tool out there. I'm just showing you Revit, but irrespective to which BIM tool you're using, you have this parametric modeling where you can select a specific model, and then you can change the value and it gets updated, right? So this is the conventional style. Then there is dynamic style of modeling, where you have visual programming embedded with parametric modeling, right? So this takes it a little further, where your model kind of gets visualized and influenced by this parameter very quickly. Like even so in this process, since we are talking about a very simple cube, uh, it is very simple. I'm just changing one parameter and hitting apply for it to work. But let's talk about parametric modeling when where it has to be dynamic in terms of taking a design like taking design decisions, right? So I'm just going to create a new conceptual mass. um, or I already created those. I'm just going to open those for now. Okay, so this is a conceptual mass which was created. Okay, what is a mass? It is basically like a block figure of any building, doesn't matter what it is, or even an element, not even a building, it could be anything. Okay, for this example, I'm just considering this to be the building. Okay, so I'm just going to delete it. I'm not going to use the one which I already made. I'm just going to show you how I created it. So there's something called as dynamo, which actually takes this parametric modeling to a next level where you can do the whole modeling very quickly and then change the parameters. So first of all, you might ask, why is it actually useful, or what is it? So when you talk about modeling, I'm just taking a step back once. So when you talk about modeling, it is almost like a virtual sculpturing, right? So okay, I should have typed something else once again. Mm, okay, let me give a better understanding of what this visual programming is, or this parametric modeling is. Uh, Let us take so any statue, or any sculpture which is created, you have a process of taking the biggest rock and then chipping out what is not needed, and then ending up with the actual idol or whatever the statue you want, right? So this is subtractive way of modeling, where you take a big piece and then you keep on removing the material until you get what you want. Then there is additive. So there is additive modeling, where you have bunch of scrap metals, right? These each part is like a individual scrap piece, like a nut and a bolt, and you're welding it together. So you're adding one small information or a small model to the existing one. So this is additive process. So basically you're adding more to a smaller piece and making a sculpture or making a model. And then you have this parametric modeling, where everything is parametric. So when I say parametric is I'll just give you an example. Okay, so there is a script which I wrote. So although this might be looking a little too much, or for people who don't know what this is, it might look a little extensive, but be with me. It is easy. I'll explain. So okay, so what I basically did, okay, so this is just an interface. Don't worry about the tool as such. Just get the concept, the whole understanding. Why I'm talking about this whole thing is for you to grasp the concept. So what we are doing right now is I just took a rectangle, right? So this basically creates a rectangle, and it basically gets length and width parameter from this number slider. So if I change this, let me change this to automatic. So if I change that to automatic, what happens is as soon as I change this information, you see the model also reflecting it. So it is highly parametric, it is dynamic. That is what this visual programming with parametric modeling is, right? So the width and the length, they change then and there. So I, as a designer, or you as an engineer, you can decide the shape uh, visually. You know exactly what you want from this. Okay, let's say I am happy with the rectangle which I got. Okay, so once I have my rectangle, I will kind of work with how many levels does it need to have, what is the total height, how level of each height, and let's say I want to twist. Okay, for now let's not talk about this. Okay, and then okay, so let me see if hold on, I'm just searching for the right. Yeah. Okay, so once I decide on the total height, okay, let me just bring this. Okay, so once I decide on the total height of the building, and then I decide on each level height, I'll copy those slab outlines you can consider. So this is like a slab outline. So once I do that, I want this whole twisted building thing, right? That's the script is that. So I just want to twist it. So I want to see how it looks. So I'll just twist the slab to a certain degree. Okay, so I can type in my angle. So from start to end, I want it to turn by 90 degrees from its center point. So I added this whole script with that concept. So basically it'll twist itself. So once it's twisted, I want to see how it twisted and make a solid out of it, right? So that's how it'll work. So you see, it's very okay. You can see it twisting. Okay, so um, okay. So what is the advantage on this is at any point of time. Now I am still working on it, and at any point of time I decide no, this doesn't work for the site which I'm planning to work on, and this cannot be a square, it should be something lesser size. So at any point of time I can change the size and it will update itself, right? So that is the most important thing on this. Like at any point of time during any design phase, I can change it. I can change the heights of it. I want to increase the height, and it'll reflect as soon as you do that. You see, I want to change any other in between level heights. So let me change this back to 10. And maybe I want it twisted a lot more. I can do that as well. So it's nothing is frozen. Like you have total control on your design. You can change anytime whatever you want. And once you finalize once your initial design phase is almost done and you're ready, you can just bring this back from this environment to here. Okay, so I wasn't showing you the previous environment. So let me just take a step back. Okay, so as I was playing around with my script here, it was actually making a ghosted, like a transparent ghosted family in my Revit interface as well. Okay, so once I'm all right with this, once I think, okay, the form is good and I'm okay with what I have, I'll unfreeze it. As soon as I unfreeze it, it comes into the Revit environment. So maybe I'm okay with this building shape. So what I can do is I can just save this as and keep it aside. For now, I'm just not going to save it. And this is the conceptual shape of the building. Let's say I want my building to look like that. So what I will do is I'll take it into the project. I'm just starting a new project. I will load it into project, load this thing into project and locate it. Okay, in the project, I'll make a 3D view. And as soon as I have my 3D view, I can see the mass, right? This is the mass family which I created with Dynamo. So you see, at any time I could change it in this environment, in mass environment, and then bring it back to Revit. Now, once I have it in Revit, it becomes very easy for me. So I can go to north. Maybe I want to add more levels. So I am just arraying the levels, let's say 10. Okay, so it added 10 levels. I'm going to array usually creates groups, which I don't like. So I'll ungroup it. And then under view, I want to create plan views for each floor. Okay, now you see all floor plans are created. Right, so you see the building at every floor plan, how it is being twisted or whatever is the twist angle. Okay, then in 3D or this has been a functionality in Revit for a long time, like the massing. There is massing inside. What I can do is I can select the mass. I can say floor mass. I can say which all levels are actually creating a floor for it. Then it'll split this according to that levels which I created, you see. Okay. Now it is very easy. So as soon as I do that, I can select all these and say I want a floor. I create a floor. Okay, so one second. Okay, as soon as I click that, floor is created. I want to create a roof. I can select roof. I can create roof. And then I can create a curtain system from any face. So picking is taking a little more time. Okay, and then I can create that system, and that's it. That's my building. I have a dynamic shape. So one good thing about this is at any time I can go back. Maybe I want it of lesser height. I can do that. I can bring it back to the project, and all I have to do is select that specific floor, and then I can say update to face, and it will update automatically. So if I change anything, it will update automatically. So you see how quickly I can create a model which is reflecting the design intent, right? And as you know, in Revit, you can just create sections however you want, and you can see those sections. So you have floors according to the twist and turns. They're cut correctly, and you have the documentation also done perfectly. So very quick interface, and you can see the potential of dynamic modeling as such. So you have a very parametric way of modeling things. Yeah, I think we are close to ending this session, so I will stop here.
Hello.
Yes.
Uh, Sir, do we need any programming language prerequisite knowledge to use a Dynamo?
No, you don't. That is the best part. So if you kind of understand just basic, uh, so you don't. To answer your question, you don't need to know. But if you're going to do extensive uh, uh, functionality or extensive parametric changing, then you might want to learn a bit about bit of coding, which could be C coding or Python coding. Python is also very easy software to learn, or easy coding language to learn. It is, if you see a Python code, it is like reading. You can understand it. So to answer your question, no, because you see the nodes which I was working on. So basically this is rectangle by width and length, right? Plane, what plane it has to create a rectangle. Width, to give a width parameter, I added number slider. So it is basically creating a rectangle by just these information. So all you need to understand is, in visual programming or in Dynamo or Grasshopper, there are many tools like this, but uh, in from a node, anything which is coming from the right is like output. Anything which is going to the left is input. So basically all this is input information, and this is output information. So for this node to work, it needs these inputs. Once it has that information, it will give out this output. That is all it is. And all these connections are basically you're giving it an input value. That is all it is. So yeah, you don't need to know any programming. You can just jump in and start with basics. There are quite a lot of video tutorials out there in YouTube. Just look for Dynamo or Grasshopper visual programming. You can learn everything there.
Any other questions? One question, quick question before we take a break, Trinath. There was this was a question asked in some forum that I was reading. BIM, I think, has this reputation of being the magic bullet that it will solve everything. But as any other enterprise without human interference, it cannot work the way that it is intending to.
Yes.
But there was one component which I was curious. Let's
Mhm.
say I have a four-storied building under design, and then the recent ECBC um, mandatory compliance for commercial projects.
Yes.
Um, can that be integrated into BIM, because that has huge amount of data, like permutations
How?
of combinations of materials, methods of installation,
Mhm.
and how much energy would they save, and where would they save, and how to use it in combinations, things like that. So
Uh,
is that, can we integrate that?
Yes, it is very interesting question. I actually also teach in JNTU Hyderabad for EMAC course, showing how these programming tools can be used to get energy analysis and how they can be embedded with ECBC compliances. So it can be done. There are programs which do it, like in Dynamo there is a plugin called as Ladybug, which I actually hope to show today, but I did not get enough time to prepare for it. But there is something called as Ladybug tools, which specific, which is like a freeware. Okay, there are many tools out there which does these, even the conventional design consultant, I think, and then Ecotech used to do it. So the thing with Ladybug tools, it is a freeware. There is no chance for future they are going to sell this software. So if you have like Rivet and Rhino license already, you can just add this plugin to it. But what it can do is, like, it does all the energy simulation. So you can get climate data plots, you can do sun path graphics. Then this is all Ladybug. Pretty much what Ladybug can do is all outdoor analysis. So anything which has to do with outdoor analysis. But uh, Honeybee, what Honeybee does is more into internal energy simulations. So it actually does annual daytime daylight studies, illuminance studies. So yeah, we are there. Like actually, this can be used with with conjunction with generative tools, and have a feedback loop from the software telling you that this at this specific location, if you choose something else like a different material or different thickness of the wall, you will save so much energy. So that feedback loop can also be got from this. So yeah, we are getting there, but of course you need to create the scripts for that. It is not that simple as I'm talking, but you see, even the simple script which I have for this twisting of a building, uh, of course it looks kind of complicated right away, but this is the easiest script which you can have. So there are there, we can do it, uh, but of course,
I
because
think
these yeah,
sorry.
because these rules keep changing, we have to update these scripts as
Exactly.
well.
I
Yeah,
was
so
just about to say that. Just
yeah.
about to say that. Being in the design field, in the practice, the biggest challenge is trying to catch up with the code compliance, changes in the building codes,
Yes.
frequent new softwares to be learned. It's a big challenge, yeah. And then
Yeah.
building code itself is I mean, as far as we can see, BIM is mostly used in India for outsourced projects. So probably we are using US code or UK code, not
Mhm.
using Indian code for Indian buildings, because the code is not built into this.
Yes.
So now this new ECBC compliance is again big challenge for practitioners. Yes, I totally understand. We are constantly in the learning curve.
Yeah, I think it is with the new technology as well. Like in any field, doesn't matter, because it is like still evolving. You have a lot of information or which is being added. The technology keeps changing every day, and we have to catch up to it and learn it to eventually, even if we kind of skip it now, eventually it'll get to a time where we have to learn it. I just recently was seeing a video, and they are basically a training company which teaches these visual programming. And the course, when he was starting, he was explaining what they teach, and he was like, for those people who are still using CAD, we can also teach that. So they are at a level where AutoCAD is like nothing. Like it is known by everyone. And one good example which I can give is my nephew, who is in eighth standard, in who's he's studying in US. He's actually learning Revit, and that is like the
Yeah.
that is the educational gap, I guess, from how it is in India to how is it internationally. People are like getting exposed to different technology right from the beginning, and they are learning all these new advances so that they are up to speed as soon as they are in the industry. So it is really interesting.
Mhm. Yes, totally understand. There is
Yeah.
a lot more that we could talk, but I would let
Yes.
everybody go. I'm sure everybody's hungry.
Yes.
Let's take a break and come back at 2 to continue your afternoon session.
Yes.
Thanks for all the participants for joining. Um, we'll see you at 2.
Thank you.
Thank you.